Hello, everybody, and most welcome to this Telenor IoT webinar on the topic of 5G for IoT. Where are we now and what's next? My name is Martin Whitlock. I'm the CTO at Telenor IoT. And with me today, I'm very happy to have Jonas Karlsson.
Yes, my name is Jonas Karlsson, as you said, and I work as a product manager at Telenor IoT. And I work with our managed connectivity, and part of my work is to look into new technologies and how to enable them for our customers.
Then I believe you're the right man for the job today here in this webinar, right?
Let's see.
Yeah. So first, before we start, I'd like to remind everybody that there's a chat function where you can post questions. And towards the end of this webinar, we will pick them up and try to answer them to the best of our knowledge, right?
Great.
Cool. But let's jump straight into it with the most obvious question. 5G, what is it?
What is 5G? Yes, yeah. 5G, I think everybody knows that that's the fifth generation of cellular communication. So you have 3G, 4G, and now 5G. You had 2G before that. And they are all standardized by a standardized organization called 3GPP. So that's the third generation party project, quite strange acronym. But they are the one that creates these standards. So they have done the 2G and 3G and 4G and 5G. And it includes a lot of things. So I think it's quite easy to underestimate how many things that actually are inside 5G. And it's not one technology, it's several. It's that we are going to talk about today. And one thing I think we can start with is that before 2G, 3G, and 4G, quite a lot aimed for mobile usage, mobile phone usage. And if I bring up a picture here. So we have a picture here. It's from the EU, the European Commission. It's a report about 5G rollout. And in the beginning of that document, they have this picture showing a summarization of what is 5G all about. And if we look at that picture, we can see, yes, you see some people. They probably have 5G mobile phones. It talks about apps. But actually, the rest of the use cases here are what we would say are IoT scenarios. So you had smart grids, you have car-to-car communication, you have smart parking, water quality sensors, smart mobility, utility management, etc. So 5G is really aimed for IoT scenarios compared to earlier technologies. Yes.
Yeah, and I'm personally most intrigued by what's up right there, entertainment apps beyond imagination. I would like to ask you what that is, but it falls without saying you can't say what it is because it's beyond imagination. But I agree, it's a nice picture and cool to see that there's so much going on with this 5G standard that goes into the IoT space.
Exactly.
Of course, we're very much active as well. But 5G doesn't really come out of the box just like that, right? There's a process to get to the specification, to the standardization and so.
Absolutely.
What can you tell me about that?
It's a quite long process. And as I mentioned, we have this 3GPP, this standardization organization. It's a global organization and it's built up by different standardization organizations all around the world. So they are responsible for creating these standards. So they are creating technical specifications that are used by device vendors to create the new versions, but also the core vendors and infrastructure vendors, how that should be deployed and implemented to be able to work globally so that one operator could talk to another operator. So it's important with the standards. So they work with releases, and they have different numbers. So it began with 2G and continue on. So they are doing a lot of work, and then they have a release with new functionality and improved functionality over the years. And maybe if you look to the timeline for 5G, I would say it started like 2010. It was the starting point of talking about the 5G.
Quite long ago.
It's quite a long time ago. And in the beginning, 2012 to 14, it was a lot of early research. And trying to find what requirement that should be put into this technology. And going forward, 2015, the 3GPP organization were stepped in and started their standardization. So they started their work and continued for some years. And the very first version of the 5G standard were released in 2018. So it was the release 15. A lot of focus on the new radio interface. So back in the days in 4G, you have 4G LTE radio. And with 5G, you have 5G new radio, it's called. And that's a big improvement. It's much more efficient in general. It handles time division or frequency divisions in a better way. But also, it also specifies more frequencies. You have access to more frequencies.
And that's important for operators like us, right?
Operators see frequencies as their goal. To be able to, the more frequency you have, the more capacity you can deliver to your customers. Also included in that release were the concept of 5G NSA and 5G SA. And 5G NSA, it's non-standalone. 5G SA stands for standalone. Non-standalone was the possibility for operators to go to market with 5G at an earlier stage. Because 5G SA, there you need to have the full, complete 5G implementation with the 5G core and the 5G radio. 5G NSA, non-standalone, it have the new 5G radio, but it do not have the 5G core. So they can use 4G core together with 5G new radio to come out earlier.
Thereby utilize the spectrum for 5G without having the full core in place. Yeah.
And the big benefit is that they can have then the higher throughput that 5G new radio gives you.
That is important.
Exactly.
And then from 2018, deployment started.
Exactly. That was the first release.
Yeah.
And the next step is that there were operators that actually released this.
Yeah. And then 5G is done?
No, it's not done. It's not done. Yeah, there were a competition to be first, but no, that's not done. So it's a long process, a lot of evaluation or evolution, I should say. So 2020, there were a new release, release 16. When release 16, if release 15 were focusing on 5G radio and non-standalone, the release 16 were instead focusing on the standalone scenario. So there they pay a lot of attention on the 5G core and those features that can be enabled by 5G standalone. And you probably have heard about network slicing, edge computing, ultra reliable low latency, a lot of acronyms. So by that, for example, to achieve a really reliable communication with really, really low latency, you need to have network slices that dedicate resources to be used in specific use cases. And also edge computing is that you have the possibility to actually use your software closer to your devices. You're distributing your software out in the network, so it's a really close distance to have the really lowest latencies. So a lot of focus on that in 2020.
And I guess that's when we come to the use cases that many people might relate to when it comes to 5G, when we have those super advanced...
Absolutely, yeah. Absolutely. So we have been talking about this for a long, long time. But yes, that's totally correct.
Self-driving cars and stuff like that.
Exactly. That's the typical use cases. Also worth mentioning in release 16 is that before 5G, we had other network technologies called LTM and narrowband IoT. They are really important for IoT scenarios because they are for small sensors and a lot of use cases can be solved by that. They were based on 4G and 4G core. With this release, 3GPP included them in the 5G core. So you can have a 5G core still using LTM and narrowband IoT. You see this acronym MMTC, that's massive machine type communication. So that's actually those two technologies.
And the importance with that is longevity of the technology life cycle, right?
Exactly.
I guess that a lot of our customers and listeners today have, some of them at least, challenge now with 2G sunsets going on in the world. But this is something that gets us into the next phase also with narrowband IoT and LTM.
Absolutely.
And it continues to be a relevant technology for 5G era as well.
That's true.
Yeah, very good.
And then 2022, so quite recently, we had this release 17. And once again, a lot of improvements and new functionality. You have more frequency again. Now we are talking about the millimeter wavelength. So really high frequencies. By that, you can have extremely high throughput. They can't reach so long, so it's more like for indoor use, but that's really beneficial as well. And there are a lot of other functionalities also added in this release. But one thing, for example, is 5G RedCap, it's called, and non-terrestrial networks.
Yeah, and I think let's pause here for a bit, because I think both RedCap and maybe non-terrestrial networks are concepts that many are curious about, because it's a lot of buzz around that right now. And maybe we should start with RedCap. What is that?
I have a picture of that.
I thought so.
Yeah, maybe we have prepared. Well, so 5G RedCap, reduced capability, it stands for. And I think we need to talk a little bit about 5G in general before we come to what it actually is. So normally when we talk about 5G, we say that, okay, we have three main areas, and one down to the left, to the right, you have this massive machine type communication. That's the narrowband IoT and LTM. So that's for use cases that need really small and cheap devices. They don't have high throughput. It can be like a temperature sensor, for example. But they have really low power consumption. So they can have battery life for like 5 years or more. So that's one part. Quite high latency in some cases. Then,
but we should say that LTM is also a little bit in between, right? Because narrowband IoT for sure limited, but LTM can handle quite a lot of data.
Compared to narrowband IoT, you need to know that narrowband IoT is extremely low throughput and also long latency.
Yeah.
We are talking like 10 seconds sometimes. So totally true.
But compared to, for instance, 2G and 3G, LTM is very capable.
Absolutely.
But maybe not compared to the technologies that are in the
not,
other
not
parts
compared
of this
to the other 5G technologies, it is not. So at the top, we have the 5G new radio used by non-standalone. So there you have what we are talking about, 5G, or we are talking about enhanced mobile broadband. So it really uses the new 5G new radio and can have really high throughput. Normally used in 5G non-standalone. And then to the left, we have the 5G standalone scenarios, the ultra-reliable, low-latency communication scenarios. We talked about slicing, edge computing, etc. But both ultra-reliable, low-latency and enhanced mobile broadband, they are quite expensive devices.
So I guess that's the trade-off in this triangle, right? So if you're on the right-hand side, you could have low power consumption, cheap devices, but you won't get the full speed.
Totally.
And then you need to prioritize.
Exactly. And then 3GPP realized that there are a lot of use cases that are not at one of these extremes. So they are more or less in the middle. So 5G RedCap is in the middle of these. So no, it's not as low latency as ultra low latency. It's not as high throughput as this enhanced mobile broadband, but much higher and more capable than this low power wide area technologies. So they are seeing a possibility to use 5G new radio, scale it down to make it possible to do cheaper devices, smaller devices, more energy efficient compared to a lot of other things, compared to the standard ones that we had before.
So a little bit of everything, but not extreme.
Exactly.
Good. I think that is something that will actually make a difference to a lot of use cases going forward. Seems quite well defined in that sense.
Totally.
But
agree.
Moving on then to the other concept we also had on the latest or the release 17, the non-terrestrial networks.
Exactly.
Are we taking cellular to space now?
Yes. So this is the space race. So non-terrestrial networks that were introduced in release 17, it doesn't need to be satellites. It can be other things, that you have the base stations up in the sky. It could be a Zeppelin or something like that. But most of the time we are talking about satellites. And satellite communication have been around for a long, long time. We'll have it for a long time. But the legacy satellite communication, they are using geosatellites that are really long away from Earth. They're really expensive. And also the devices were more or less always unique for this scenario. So you need to buy a device that only could communicate via the satellite and nothing else. And though most of the time quite expensive.
And the antennas, special antennas and everything.
Everything, often really big ones. So with release 17 and this standardization, it's now possible. The race is now how to enable satellite communication, but to standard IoT devices and standard mobile phones. So there are different approaches. Some are using the frequencies that are defined for satellites, LNS band. Some are teaming up with operators and actually borrowing their frequencies. They need to turn it on when they're passing by a specific country, and then they turn it off. It's quite amazing, but it works. But it's and also the concept of LEO satellites, low Earth orbit satellites, have made this possible, because now it's so much easier to get satellites up to space, much more cost efficient. So yeah, it's a big race going on.
But they typically move around.
The typical move around, and we have different concepts there as well. If you know, one of the most common one is Starlink. So they have a huge number of satellites going from east to west. And you need to have a lot of satellites to do that, because otherwise you won't cover the whole Earth. Others, the new ones that maybe aim for like low throughput, narrowband IoT scenarios, for example, they have instead satellites going from pole to pole. So the Earth is turning this way and the satellite that way, and then you will cover the whole Earth.
But maybe not simultaneously.
Not simultaneously, but if you have enough satellites, but then maybe it's enough with 200 instead of 2,000s or 5,000s.
Yeah, it's super interesting.
Yeah, definitely. So yeah, the future will tell.
But you will then, with this technology, be able to connect to these satellites using more or less the same terminals as you do with normal cellular.
Exactly. And it's you will see it as a hybrid scenario. So normally you would like to connect to a base station on Earth, because it's going to be better performance and cheaper.
More capacity.
Exactly. There are limitations to be up in space. But you have a really good backup. So if you have a rural area where you can't get connection in normal cases, this could be a really good addition.
Great.
Before we continue, I just one more release, and then I'm finished with this timeline here. So just recently we had the last release from 3GPP.
Last or latest?
Latest.
Yeah.
Because they're planning for many more.
I guess so, yeah.
Yeah, you're totally right. But release 18, when you hear about that, you're going to hear a lot about 5G Advanced. 5G Advanced is not like a specific feature. It's more like a brand name. They did the same in back in the days, 2011. LTE became LTE Advanced. The same here. But in this, it's more improvements, once again, better frequencies and stuff like that. Also RedCap is going to be enhanced. So it's called Enhanced RedCap. If the first release were aiming for like 100 megabits per second to 200 megabits per second, at that scale. Now it's closer to the low power wide area technologies like narrowband IoT and LTM. So the next release is going to be more battery consumptions and stuff like that. So that was really just released.
So then I must ask a question here, because we're talking about enhanced RedCap here already. Do we even have RedCap out in the market before we get the enhanced RedCap specification in our hands?
That's true. It takes time.
Yeah,
it takes time. So
what is the status here?
Yeah, the status is that it takes time, and we are really glad to always talk about this really early, so our customers expect it to be available. But it's quite a long journey, and it takes time because 3GPP starts with this development of the standards. After that, they hand these specifications over to device vendors and core vendors and stuff like that. And then the operators need to buy these platforms and solutions and implement it and start rollout. It takes many years. So no, you don't have 5G RedCap all around. That's a fact.
No, and talking about facts, then how many operators, for instance, have RedCap released? Where are we?
We have a slide here. So this is from GSA and Ericsson Mobility Report, and it's April, May. They released their data, so we put that together. So if we look at how many operators that have invested in 5G, it's a lot. So it's approximately 600 operators that have started to work with 5G. Out of them, we have like approximately 300 that have released 5G NSA, the new radio, and then enhanced mobile broadband. A little less, 50, have managed to deploy some sort of service on 5G standalone. So not as many. And
even,
now,
even here you can see, 600 operators have started investments, 300 released, and it illustrates a little bit how this works, right? Because as an operator, you need to build physical base stations with this technology, and first you need to build up a sufficient coverage, most likely, before it makes sense to launch the service, and that's what takes time, right?
It takes a long time, a lot of money also.
Yeah, exactly. So you get the specification done, then the equipment vendor can lock in their designs and start to produce, and they need to produce and then ship, and then you build the networks, and then you can launch.
Exactly.
And then it's a continuous journey to upgrade.
Also important to know is that the operators are not, they don't need to deploy all the services in a release from 3GPP. They can pick and choose. So some services they don't see the business case for. So it can be really great on paper, but they don't see that customers are willing to pay the money it costs to actually deploy that. So that's also a fact. But coming to RedCap, RedCap is dependent on 5G SA. So you need first to have 5G SA before you can have RedCap. And so it's only 17 operators that have said that they have invested in RedCap, and out of those, 4 of them have released. It's the 3 major in China and 1 in Kuwait. So they are still at a very, very early stage. But as we saw, it was 2022 and 2024 the specification was done. So it's quite a journey before it's fully deployed.
And now we have a new specification for enhancements of what is now launched by 4 operators.
Yeah.
So I think it's interesting to reflect upon that, because as said, it's something that is heavily discussed right now, and a lot of buzz around RedCap, but this is the time it takes basically to get it out in the market. Then you need to have device manufacturers hooking up and all this for the ecosystem to be there. But surely it will be something that a lot of IT deployments will rely upon in the future, and
absolutely
we need to continue to monitor that development, obviously.
Absolutely.
And maybe another thing to consider is how to access those networks, right? Because at least at Telenor IT, we have a fairly good or very good footprint on roaming. And that is
exactly
what most of our customers are utilizing when they go global, right?
Totally true.
But also these new technologies like SA and RedCap and so on, they have also to be enabled for roaming, which probably won't happen before an operator have launched the technology. There's a lag here. So that's important to remember as well. Of course, it's our job to make sure that we roll out the roaming agreements as quickly as possible.
Absolutely. And they will start focusing on getting it out and ready locally before they start working on roaming. The good thing with 5G NSA is that is really a great availability for roaming already, because it reuses the 4G roaming. So it's quite easy for operators to turn that on. 5G SA will be a different story. It will be a little bit more complex, so that will take longer time.
Yeah. And then also with regards to deployment, and because what's not visible here is where on the market these technologies are activated. But it's not a given that just because you as an operator have activated 5G, it could be NSA or SA, it doesn't have to be nationwide from day one. And usually it isn't. Usually it's in the cities, right?
Definitely. When it comes to 5G, that's really the case. So they start to deploy it in dense areas, big cities, and then spreading it out. So that's quite common. So you can have an operator that definitely have 5G, but not fully coverage.
And the reason is, of course, that you want to get the frequencies that 5G comes with, where you need the capacity, and that's where people live usually.
Exactly.
So
Still, I think the end game definitely will be that they are aiming to do the full rollout, because it's so much more efficient compared to other technologies. So this will be really beneficial for the operators to deploy this totally. But it will take time, and they need to start prioritizing in the beginning.
Yeah, interesting. But so it's a complex landscape, right? There are a lot of technologies, and even though we said that we were going to talk about 5G, I know we have been throwing 5 or 6 different technologies in the mix already.
Exactly.
Given that, if I turn to you then, what would you be recommending, or what would you yourself start to considering as a technology if you were to deploy an IT solution today?
Yeah. As we see, it takes time for new technologies to reach the market. So therefore, what I think is that you need absolutely to start looking into those. You need to see what use cases can you benefit from. What can you offer your customers with these new technologies? Because it's going to take time before you have that up and running. And you also need to secure that you are future-proof and look at that. But at the same time, you can't sit and wait. You can't see that, this 5G RedCap would be perfect for me, because then you won't have a solution for a long, long time.
Unless you do business in Kuwait. And
China. Exactly. You are some spots that are going to be able to do that. But so therefore, you need to look into what exists in the market today, and that will continue to exist for a long, long, long time. So just a short recap of these existing technologies that we see that are global available. So starting off with the low power wide area technologies that we talked about, the LTM, narrowband IoT. So this is really low throughput scenarios in general, sending a little bit of data, but not so often, but really good power consumption characteristics, can have battery life a long time. They have even special features for extended coverage, so that they can penetrate in buildings and stuff like that better than other technologies. You need to know that narrowband IoT, as we talked about, is really, really low throughput, but also have a really high latency. But another disadvantage is that it's not fully global yet. Yes, a lot of operators have deployed this, and we have a lot of roaming agreement, but it's not all around the world. And also some parts in Asia, they're focusing on narrowband IoT, and the rest is more into LTM and stuff like that. So that's one of the challenges here. The next thing is LTE Cat 1, LTE Cat 1 bis. What is that? So that's actually standard 4G. When we released 4G, Cat 1 to Cat 4 was that. And
now we're talking really long ago.
that was quite some time ago. Yeah, definitely. So it has existed for a long time. But in the beginning, it was not so popular because the devices were quite expensive, but the throughput and was not so good. So it's like mid throughput. But now the prices has really gone down. So that has made this really interesting. So a lot of vendors creating devices are now creating new Cat 1 devices. So it's medium throughput. It has medium power consumption. It's not as good as the LTM and Narrowband OT, but much better than the high spec devices. If you have voice as your scenario, they can handle VoLTE without any problems. But the very big, great thing with them, the full global coverage. So almost all operators around the world are supporting this technology. So if you have a fully global scenario, this is a really great technology. Just want to mention, we're talking about Cat 1 and Cat 1 BIS. BIS, that's after some years, 3GPP released a new version of Cat 1 with one antenna. So it's a receiving antenna that in the beginning were 2 and then reduced that to 1. But that gave us that you can have even cheaper devices and smaller devices, like wearables and stuff like that. So that was that. And last, of course, if you have these high performance scenarios, you need really high throughput. Then you need to go with Cat 4 plus, so Cat high. These LTE categories are the higher the number, the higher capacity, and also the more expensive devices. So there you have 4G with Cat high and 5G NSA for these really high throughput scenarios. More expensive, more power consumption. VoLTE, of course, can be handled. Quite good coverage. It's especially Cat 4, of course. That's the same as Cat 1. But 5G NSA it's on a good way as well.
But you could almost see here that you have a scale of things, right? So you have on the LPWA side probably a lot of things like utility and metering cases and all that. And
Absolutely.
to the right, you have connected cars with a lot of data traffic going on. And in the middle, there's something for everyone. But
Exactly.
That's a decision you got to make when you design your solution.
Exactly.
And maybe just a bit of commercial then on that. There's actually a white paper you can download on our website that we have released now in for a number of years in different revisions where we look at the different technologies that we have at our disposal to guide as a help. So that could be a good start if you're considering which technology to use. But in that paper, we also look at the different aspects that you do need to consider when you make your choices. And of course, one is the technical, right? Where you need to consider what kind of coverage profile do you need. I mean, maybe you're fine with having the coverage in the urban cities because that's where your use case is going, and you want to have the high throughput, and 5G is your thing already today, right? While you might, in other cases, have to consider 2G because that's what still is the dominant coverage in some markets. So you need to take that into consideration, and 2G or LPWA, for that sake, could be fine because you don't need a real-time application, really. The commercial part is, of course, important as well. You need to keep your bill of materials low and make sure that you have a solution that scales well. So can you afford the high-performance modems, or do you need to keep to something less capable, and you're fine with that? I also think that the ecosystem part is important, that you consider which suppliers are available, how many devices are available. It could be something to consider for the RedCap, for instance, now that this technology comes in play. Do I have sufficient supply chain for RedCap to take the step into it, or do we need to wait a little bit? And what's the reach globally and so on, different frequencies and all that. But I think all these things cannot be considered unless you know what use case you want to fulfill, right?
Exactly. You should always, that's the baseline. what we want to achieve.
Yeah,
what do you need?
We have a lot of technology at our disposal. Apparently, we've been talking about a lot of them already today. But unless you know what you need to achieve with your use case, if you know that, we can help you select the right technology for it, I think. Yeah.
Absolutely.
So that's good.
Okay.
But looking then a little bit forward here, Jonas, what's the outlook for 5G in terms of uptake and compared to other technologies?
We have a picture here. It's not only 5G, but it includes definitely 5G. So this is figures from Berg Insight. So they do calculation and prediction on how many devices in different technologies. So each color here is one technology, and you have a timeline, and until 2023 it's real numbers, and then after that is prediction, what they are seeing happening in the market, and the numbers are in thousands, if you're wondering. So and also I need to mention that I removed China actually from their figures, and the reason is that China has such a lot of devices already, and also they're really leaning into narrowband IoT. So that would have taken over the whole shot. So therefore I removed that, but you can know that, okay, China, narrowband IoT and Cat 1 is the biggest one there. This goes up to 2028. So here you can see the prediction of what we will have in 2028. And looking into this, you can see that the yellow one is the Cat 1 and Cat 1 bis, and they are actually predicting that will be the most used in 2028.
Which is fantastic because it's a 4G technology, right?
Exactly. But that's actually, I think it's...
Makes sense.
Yeah, it makes sense because it shows that the IoT market moves much slower compared to mobile. This is not mobile phones.
No.
That's important to know as well.
It's only IoT devices.
It's IoT devices. And if we have had mobile phones here, it would be a much higher penetration of 5G because people are swapping phones quite fast. IoT scenarios could be a lifespan of 10 or even more years for one device. So it takes time for the device to be upgraded. And look at 2G, for example. You can see it has actually continued to grow.
Yeah. Peaking this year.
Yeah, it's peaking this year.
At the same time as a lot of our customers are wondering how to handle the 2G sunsets.
Exactly. Yeah. So you need to respect that it takes a longer time. And as you can see, the biggest one is Cat 1, and after that is Cat 4 plus, the higher specification for Cat LT, and then LTM quite a lot as well. But 5G and RedCap not as much. That is not that it's not going to happen. It's just that it takes time. So that will be extremely good, but I said 30-year-old technology like 2G still peaking.
Yeah, fantastic.
So it will come. It will come.
And then a final thing, this is number of devices per technology, but I guess that if we would have applied data volumes per technology, it would look different, of course, because
Absolutely.
we have narrowband IT, very low bandwidth, and while the 5G and LT, Cat 4 and so on can handle so much more data. So maybe
exactly,
if we're looking at it that dimension, it probably would look a little bit different in distributed on traffic.
Absolutely.
All right. So, Jonas, thank you very much. I think we covered a lot of ground already. I do think that we have a few key takeaways from this, which is, of course, that we have said it so many times. It will take time for new technologies to be penetrating the market and become globally available. And that is just something that we have to accept and live with. We need to understand it, and we need to look forward, because the second bullet here, look at the use cases and start investigating those, because I'm sure that we also have some lead times in the business development part, where
Absolutely.
What do we use, what use cases should we realize, and so on. So starting to work with that in parallel to when the technologies are being deployed could be a good idea if you want to be early out and take advantage of the new technologies that will come.
Totally agree.
And then maybe finally, and as a CTO, I say this too often, I guess, that don't start with the technology. Trust me on this. Start with your use case and what you want to achieve with your business, and then select the technology, because doing the vice versa could lock you in to a technology choice that turns out to be not optimal for certain reasons. Even if you go with the latest technology, we've seen that it takes long time to
we've
get
seen
it available.
examples of that. So
and then you're limited by coverage.
Exactly.
Which is probably not what you want. So, that would be the key takeaways from my side, at least. Anything to add?
No, I think you summarized it really well.
Yeah.
No, I totally agree.
Good. Then let's see if we have any questions from the audience. And I see that we have one here. And that goes to voice. Why didn't you mention voice in LTE-M?
Yes. Okay. So LTE-M do support voice, technically wise, in the specification, but it's a fact that a lot of operators have not enabled that. So as we talked about, that they can pick and choose. So yes, it could, but not many operators have decided to do that. So therefore, I didn't mention it.
Okay.
But it's in some areas and some operators, you will be able absolutely to do voice and VoLTE via LTE-M, but not in all operators' networks. But with Cat 1 and Cat higher, there you will always have VoLTE.
Yeah.
More or less.
Thanks. And actually, I can't see that we have received any more questions, so I guess that means that we've been fairly clear.
Totally
or we
confused.
Have straight over the heads of everyone. Hope
you never
not.
know.
But I mentioned this white paper, Connectivity Technologies for IoT. I do recommend to read that if you're interested in digging deeper. Of course, we have plenty of Telenor IoT staff around to ask as well if you want to have some guidance from us. But otherwise, really hope that you have learned something today and that you're prepared for your next IoT challenge. I am. Thanks, Jonas.
Thank you.